So obviously it will be the total number of frequencies of the first observation plus the total number of frequencies of the second observation. So cumulative frequency gets filled in as that. Cumulative frequency for the third observation will be first plus second plus third. So again gets filled in. Or you can see that the clever way of doing it, first plus second is just the cumulative frequency of the second one. So you do cumulative frequency of second plus frequency of third. Cumulative frequency of fourth will be cumulative frequency of third plus frequency of fourth. And in this manner, if you follow the arrows very carefully, you fill up all of the cumulative frequencies. Now, your final cumulative frequency, which is the cumulative frequency of the highest observation, will be equal to your total frequency. So that's always an easy way for you to check if you've done it correctly or not. Add up your frequencies and see where it is. Now, if you have an odd number of frequencies, you simply find what would be the middlemost observation. So, for example, here I have a total of 29 observations. The way to find it is that the middlemost observation, when you have an odd number of observations, is your n, where n represents the number of observations, plus 1 by 2th observation. So in this case, the median observation will be the 29 plus 1 by 2, 30 by 2, 15th observation. Your 15th observation will be your median. Now, which one of these will qualify for that? You go and look at your cumulative frequency. If any of the cumulative frequencies is equal to 15, whichever observation corresponds to that will be your median. Let's say it doesn't, like in this situation it does not. What you do is, you find the cumulative frequency that's less than 15 such that the next one is more than 15. So over here, what we see is that one of them has a cumulative frequency of 12 and the next one has a cumulative frequency of 17. Now logically, if you think about it, what this means is, up until the one that has a cumulative frequency of 12 observations have come. With the next observation, a total of 17 observations have come, which means the 13th, 14th, 15th, 16th and 17th observations must have been that particular one. And therefore, that one is your median. If you have an even number of observations, you locate your n by 2 and n by 2 plus 1th observations. If they happen to be in the same way, if they happen to be in the same frequency, then that is your median. If they happen to be in 2 consecutive frequencies, you just find their average. Like so. In these 2 cases, in one of them, both of them are coming out to be in the same frequency, so that's just our median. In the other one, it's coming out in consecutive frequencies, so we take their average and that is our median. This way, we can find the median of discrete data. Using cumulative frequency, we will also find the median of our continuous table, and we'll look at that right now. For continuous data, all we do is we have our continuous data again. So we have our classes, we have the frequency of each class. Like cumulative frequency of discrete data, we will create cumulative frequency of continuous data. Again, let's make a less than cumulative frequency. So all we do, whatever the upper limit of each class is, we just write it like that. So in this table, less than 10 will just be frequency of the first. Less than 20 will be first plus second. Less than 30 will be cumulative of second plus third. and so on and so forth, the cumulative frequency gets filled. Once again, now again find your median observation position. So whatever number of observations I have, I divide it by 2. That gives me my observation position. Like we did for discrete data, we find the class in which this median will lie in. Now the thing is, for discrete data, that just gave us our answer. Here, it doesn't directly give us our answer because it's not discrete, it's a range. So the formula for median is equal to L plus n by 2 minus CF upon F into H, where I'm going to define each of these things. L is the lower limit of your median class. Like I said, we identify where our median will be. We call that our median class. The lower limit of that class is our L. Plus n by 2, self-explanatory, total frequency divided by 2. Minus CF. CF in this case is cumulative frequency of the previous class, not the median class, divided by F, which is frequency of the median class. So cumulative frequency of previous class, but frequency of median class, multiplied by H, which is of course your class size, like we saw in mean. So the moment you learn this formula, it gets filled in and the answer will come out instantaneously. For example, I have this really big table. It seems like it will be complex. The second I make my CF column and find my median class, put it into the formula, get your answer. So in this way, you can calculate the median of a continuous frequency table. We will now do what is known as mode, and then finally a concept known as ogive. Mode is the simplest of the three. If you have a discrete table with mode, it's literally whichever observation has the highest frequency, because obviously that means that is appearing the most number of times, which is the definition of mode. If it's not discrete, if it's a continuous table, all we do is write out our table again, write out our frequencies, and that's it. We don't need to do anything else. Again, identify which particular class has the highest frequency. That is known as your modal class. Just like in median, it was known as your median class. And then the formula for mode is L plus, in brackets, F1 minus F0 divided by 2F1 minus F0 minus F2, and then multiplied by class size H. And here L is the lower limit of modal class, F1 is frequency of modal class, F0 is frequency of previous class, and F2 is frequency of next class. And that's it. Like in median, identify it and just plug it into the formula. Here, you don't even have cumulative frequency, you don't have anything, you just have frequencies, find it, and then done. If you have two classes that have the same mode, you get two modal classes, you pick any one of them that you want. Just before we finish off, here we're going to learn a very small thing known as empirical formula. And the empirical formula is sort of an experimental way of relating mean, median, and mode. Empirical formula is given as the following, and you will only use it if they tell you to find any of the observations using empirical formula. Otherwise, you will follow the normal procedure. So just an important thing to know, it can come as a 1 marker. So simple formula. Let's finish off with ogive and then be done with this chapter. The ogive. The ogive is nothing but a graph in which you plot your frequencies in terms of cumulative frequency with your classes. So there are 2 types of ogives, less than ogive and more than ogive. Let's look at less than ogive first. As the name suggests, you will be doing less than cumulative frequency. So what you do is, you have your classes, you have their frequencies. You create the less than cumulative frequencies. So less than 10, 20, 30, 40, so on and so forth. And then on a graph, you simply plot them, where on your x-axis, you have your classes 10, 20, 30, 40, 50, and on your y-axis, you have your cumulative frequency. And you can see that the less than ogive is an upward moving graph, because obviously less than 10, 20, it's always increasing. And it starts at 10, not at 0, because the first less than observation is less than 10. So your less than ogive is of this format. What about your more than ogive? Now we do not talk about more than when dealing with median, and because it's not a very common method for median calculation. But for ogive, it is a very common type of ogive. Now your more than cumulative frequency is the exact opposite of less than. So for less than, we started with less than 10, less than 20, 30, 40. Here you're going to go more than 0, more than 10, more than 20, more than the last lower limit. So obviously more than 0 is just all the observations. So you add all of them up. More than 10, again, if you logically think about it, will just be more than 0 minus whatever was there from 0 to 10, hence more than 10. So take more than 0 cumulative and subtract the frequency of 0 to 10. More than 20 will be the same as more than 10 minus between 10 to 20. So more than 10 minus frequency of 10 to 20. And like this, we fill up our more than column. Now, if you look at what happens when you draw your more than and less than ogive together, we see that they intersect at a point. From this point, if I drop a perpendicular or basically trace a line, a straight line to my x-axis, that will be my median, because obviously x represents your values, your observation, that's the range of observations. So the intersection point of ogives, the x value there is your median. Let's say you have just one of the 2 ogives. You can still find the median by finding the median position n by 2, total number of observations by 2. Locate that on your y-axis. Y-axis is your frequency axis. Draw a straight line to the ogive, and where it intersects the ogive, draw a straight line down, and that x point will be your median, as shown in the following diagrams. So ogive is also a very common 4 marker that comes. You are simply told draw the less than ogive, draw the more than ogive, and so on and so forth. So of course we will look at a couple of detailed questions on this, but the basic concept is just following the video as such. With that practice, you should be done with this chapter and can move on to the next chapter.